Welcome back to Algebra 2. Today you are going to be learning about base e and natural logarithms. So base e would be like y equals e to the x. E is known as the natural base. It's approximately 2.71828. You can find this e in your calculator. It's normally a e to the x button. So if you type in e to the first power, you will get that value. So the natural logarithm then is when we have a base of e. And this occurs all over the place naturally in science, so we use the abbreviation ln of x to represent the natural logarithm. So when you see ln of x, that means our log has a base of e. So what we're going to do here is we're going to write the equivalent exponential or logarithm equation. So this is using the same information as what we did for regular logarithms. So if we have e to the x is equal to 23, the base number is e, so that means we have the natural log here. So that means x would equal to log base e, or natural log, of 23. And remember, you can always view this as thinking about what the base number is, raised to here, and here we have e to the x. Second example, this is currently in a logarithm, so we want to write it as an exponential. So this is the natural log of x is approximately 1.2525. So here we'd say x then would be approximately, your base number here is e, so it would be e to the 1.2525. Okay, so now we're going to use our properties of logarithms to combine our natural logarithms into a single logarithm. So here we have 4 times the natural log of 3 plus the natural log of 6. So our properties of logarithms say numbers that are multiplied out in front are really exponents. So this is really the natural log of 3 to the 4th plus the natural log of 6. Well, 3 to the 4th is 81, so this is the natural log of 81 plus the natural log of 6. Next, our properties tells us that when we add two logarithms, it's really multiplying on the inside. So this is the natural log of 81 times 6, and 81 times 6 is 486. So this is the same thing as the natural log of 486. So there we're just using our properties of logarithms to combine it and write it as a single log. Next, we're going to do some solving. So here we want to solve, we want to round to the nearest 10,000th. Recall when we have our less than or greater than signs. So if we had the natural log of x is greater than y, that's the same thing as saying x is greater than e to the y. And if we have the natural log of x is less than y, that's the same thing as 0 is less than x is less than e to the y. Those are the same exact equations as our log values that we did earlier in this chapter. So for our first example, we have natural log of 2x minus 3 is less than 2.5. So we're less than, so we then know that we will have 0 is less than our 2x minus 3 is less than e to the 2.5. And we know it's e to the 2.5 because that's our base number raised to the 2.5. We'll split this up into two separate equations to solve. So 0 is less than 2x minus 3, and 2x minus 3 is less than e to the 2.5. So for this left-hand one, we'd add 3 to both sides and get 3 is less than 2x. Divide by 2 and get 3 halves is less than x. The right-hand side, you're going to have to use your calculator to figure out what e to the 2.5 is. E to the 2.5 is 12.1825, and leave it to 4 decimal places. So you're going to add 3 to both sides. So when you have 2x is less than 15.1825, divide both sides by 2, and you get x is less than 7.5912. So now notice that we have a range of values here. Our range of values are from the 3/2 and the 7.5912. So our solution here would be 3/2 is less than x is less than 7.5912. So those are the values for x that would work. Okay, second example. Natural log of 5x plus natural log of x is equal to 7. First off, we'll have to combine these two natural logs into one. So using our properties, we see that we're adding. So we really are multiplying those two. So this is the natural log of 5x times x is equal to 7, which we know would be the natural log of 5x squared is equal to 7. Converting this now to an exponent, we would have e to the 7th is equal to 5x squared. And now we just want to get that x squared alone, so we'll start with figuring out what e to the 7th is. So we would have 5x squared is equal to 1096.6332. Divide both sides by 5. We get x squared is equal to 219.3266, and then take the square root of it. Remember, when we take the square root of it, we do get plus or minus, so plus or minus 14.8097. However, this negative value here will not work because we would be taking the natural logs of negatives, which is not going to be, which will not exist for the same reason that the logarithms of negatives don't exist. So here x would just be the positive 14.8097. So there we solved our natural logarithms.